Okay, sorry to the people that are watching this, that you have to watch this. I forgot to record it again. So again, arc length, radians to degrees radians. We are starting with arc length. And arc length is going to be a fraction of the circumference. So this part is your fraction measurement, which is your degree, divided by 360, because that's the full circle, times the circumference. Okay. And this is like too close, I feel like. Better? Mm-hmm. Okay. All right. So, all these words right here are just what I said earlier, okay? So arc length, again, is a distance. So it's going to be measured in like inches or centimeters or whatever distance units it is. So we're going to find the length of this arc right here. So we need two things. We need its measure, okay, its degree, because we got to figure out what fraction of the circle that is. And we need the circumference, so we can find the fraction of that circumference. Does that make sense? You with me? Okay. So if I look here, what is the measure of this arc? Good, 90. Well, okay, you went way ahead. 90. I'm going to put 90 degrees. Okay, so if we're finding length, usually we use a little L. So we want the length of the arc. We need the 90. It's 90 degrees out of the 360, what Ezra said. And then we are going to multiply that by the circumference because we want that fraction of the circumference. So how do I find circumference here? Yes, or since they give us the diameter, it's just pi times diameter. Okay, so this is the diameter is 16 pi. But you're right, 2 pi radius or pi times diameter. Now, you can put this all in your calculator and be fine, but it says leave in terms of pi. So if you put it in your calculator, forget about the pi and then put the pi back on. Okay, but 90 out of 360 is what Ezra said. It's 1/4 of the circle, right? If I had 90 degrees, 90 degrees, 90 degrees, 90 degrees, that's 1/4 of 4 pieces. Does that make sense? Okay, so this is actually 1/4 of the circle times the circumference. So I only want 1/4 of the circumference. So what's 1/4 of 16? 4. 4 pi. And then we want to give it its units, a measure, which is inches. So 4 pi inches. That is the length. So again, the measure is 90 degrees of the arc. The length is 4 pi inches. Is that okay? You ready for the next one? Okay. So this one's a major arc because it has the 3 letters. So start at A, then you go to D, then you go to B. Remember, that's how you follow it around. Okay, so we need the measure of this arc in order to find the length. So if this side is 150 degrees, how do we find this side? Good. Subtract from 360. So 360 minus 150. Is that 210?
Yeah.
Okay. So my measure of the arc is 210. So length of A, D, B. So I want 210 degrees out of the total, which is 360. And then I'm going to multiply that by the circumference. Okay, how do I find the circumference of this?
So
18 times 2 times pi, right? Because 18 is a radius. So I need 2 18s. What's 2 18s? Thank you. I think you were saying it and I just didn't hear you. So 18 times 2 is 36 with a pi. Now, you could put this in your calculator. Do you guys know how to put this in your calculator? You grab a calculator, make sure. Every calculator is a little bit different. But really what this is saying, it's good to reduce, to simplify your fraction, but you can go 210 multiply by 36, and then that fraction part means divide by 360. You could do it that way. Or you could say 210 divided by 360 and then multiply by 36. You should get the same answer, 21. Okay? Or you could just reduce this mentally and then multiply and divide. Okay? But it's going to be 21 pi. Yes. Centimeters. Questions about arc length? Remember, arc length is a fraction of the circumference. Okay. New thing. Well, arc length is new too, right? You guys have never done arc length. Okay, here's the new thing. Radians. Okay. Radian, it's a unit of measure that we can switch to instead of degrees. Okay, that we use with circles. When you get to pre-calc, you will use it a lot because you will use the unit circle a lot, and you will deal with radians instead of degrees. There's even a mode on your calculator that you can put into radians instead of degrees. You guys remember like the scientific calculators, how there was like an RAD? That meant you were in the radian mode instead of the degree mode, the DEG mode. Okay, that's what that's about. So you're going to get a little taste of it here. So a radian right here is a unit of angular measurement equal to 180 degrees over pi. Okay, we will not use the decimal version. We will use 180 degrees over pi. That's a radian. Okay, now listen. Shh. Hey, extra talking. Okay, now the radian measure of this symbol here, this symbol is a Greek symbol. It's called theta, T-H-E-T-A, theta. We use it a lot with circles and degrees, okay? Even in triangles when we're talking about the degree and the angles, okay? So it's another way to call an angle. This is angle theta. So the radian measure theta of the central angle is the ratio of the arc length to the radius. So arc length is the L, radius is the R, okay? All right, so to convert, if we want to go from degree to radians, we are going to multiply with the pi on top. We will multiply by pi over 180. If we want to go from radians to degrees, we are going to multiply with the degree on top because we want to get rid of the pi. So it would be 180 over pi. Okay, so this is what I mean. We have 135 degrees. We want to change it to radians, okay? It says as a multiple of pi, meaning we're going to use the symbol pi and not actually push the button on our calculator, okay? So we're going to take 135 degrees, and we are going to multiply by the pi over the 180 because we are trying to get rid of degrees. Does that make sense? And we want a pi with it. So when we do that, we have 135 pi over 180, but those are ridiculous numbers. Actually, they're not. They just need to be simplified. Okay, so we need to simplify them. So when we simplify, we don't want decimals, okay? So we just need to simplify down until we can't simplify anymore. These simplify to 3 over 4, so 3 pi over 4. If you put it in your calculator and you saw 0.75, write it as 3/4. Okay, so, and you would label this radians. Okay, to go backwards, we just need to flip this thing. We need the inverse. So we're going to take our radians, 11 pi over 6, and we want to put it in degrees. So to remember this, you want to get rid of the pi. That way, if it's on top here, it needs to be on bottom to get rid of it. So it's going to be times 180 over pi. Because what happens if I have a pi on top and a pi on the bottom? Yeah, they become a 1, and we don't need that 1. It's gone. Okay, and then you can multiply 11 times 180 divided by 6. You can go 11 divided by 6 times 180. Either way, put it in your calculator. And you get 330, and this will be degrees. Questions? Okay. So how do I set up this next one? If it's degrees and I want to go to radians, good. Guys in the back, you good? Okay. Okay, this is the pi on top because I want that with my radians, right? That's how I remember it. Pi on top because I want to keep that. Okay, so I actually have 240 pi over 180. Right away, I know those zeros are gone. What did 24 and 18 reduce by? Good. 4 over 3, you can divide it by 6, right? So it becomes 4 pi over 3. Okay, last one on this side. We want to go from radians to degrees, so what do I have to multiply by? Good, I want that pi to go away, so it goes on the bottom. Because pi over pi is a 1. And then I've got 2 times 180, which is 360. 360 divided by 3 is 120? Yeah, okay, good. I got a little bit nervous there. I was like, is that right? Questions on that? Okay, really, you just need to be able to go back and forth. Okay, you need to be able to go back and forth. All right, flip. Okay. Oh, my thing bled through. All right. Okay, we're going to skip this for now. We're going to come back to it. Okay. I want to go to example 3. We're going to do all 3 things. We are going to find the central angle in the measure, right? We're going to find it in radians. And we're going to find the arc length. So we're putting the 3 things together. All right. So Chad has this dinner party, and he has a charcuterie board, which those are awesome. I really love charcuterie boards. Okay. With his favorite snacks. And we want to find the measure of the central angle in degrees and radians and the arc length. So we're doing 3 things. Degrees, radians, arc length. Okay. Now we need to know this. The radius of the board is 6 inches. Okay, so our radius, you might want to put it on there. It's hard to see with my pencil, but the radius is 6 inches. All right, so if we're rotating this 1/6 of the way, how do I change that to degrees? We want 1/6 of, what's the whole thing? 360. No, you got it right. I heard you back there. So we want 1/6 of 360, right? So we're going to take 360 times 1/6, or 1/6 times 360. And we get, what he said? Who said that back there? You got it right. 60 degrees. So this is 60 degrees. Okay. So now we want to change that 60 degrees to radians. So what do I multiply by? Yep, pi over 180. So right away I know that the zeros go. And then I have 6 over 18, which simplifies to 1/3, right? So pi over 3. You could put 1 pi over 3, but you can just leave pi over 3. Because the poor 1, we leave it out all the time. It's probably really sad. Like if it had a face, it would be like a sad emoji face, right? Like with the 1 tear going down. That's how I feel as a 1. I should just think my favorite number is 1. Would that make it feel better? Yeah. Okay. Sorry, I get distracted. Okay. Now let's do arc length. We want the length of this arc, which doesn't have a name, so I'm just going to put an L. Okay, now remember, it's going to be the fraction of the circumference, right? So do we already have the fraction? Yeah, we have 1/6. So we just need to multiply by the circumference, which would be, if the radius is 6 inches, good, 12 pi. So what's 1/6 of 12 pi? Yep, 2 pi. And it's inches, so 2 pi inches. So we've got 60 degrees, pi over 3, we need to put radians. Radians. And then 2 pi inches. Bless you. Okay, next one. This time we're going all the way around 3/4 of the way. So we've got 3/4 of the way. We want to change that to degrees. So we want 3/4 of 360, right? So 3/4 of 360, 360 times 3/4, or vice versa. What is it? 270. Thank you very much. Degrees. All right, how do we change that to radians? Perfect. All right, we know the zeros go. 27 over 18. What does that simplify to? Yeah. So 3 pi over 2 radians. Perfect. Okay, do we already know our fraction of our circle? C. Yep, 3/4. C. Okay, multiply by our 12 pi doesn't change, right? So 12 pi. So we've got 3 times 12 divided by 4, or 12 divided by 4 times 3. I like 12 divided by 4 times 3. That's 9, right? 9 pi inches. Bada bing, bada boom. Okay, questions on that? What questions do you got? We good? Okay. Again, we'll come back to the big circle here in just a minute. Let's go down to Okay, let's go back down. Let's go down to here. All right, so example 4 says, think about it. If the measure of a central angle theta equals, remember this is arc length divided by the radius, then what is the length of the arc with the related central angle? Okay. So all we're doing really is switching this around to get L equal to whatever it is with theta and R, right? So if I have theta equals length over radius, if I want to know what length equals, I would just multiply by R. Does that make sense? Okay, so if I multiply by R, that gives me length equals R times theta. Or theta times R. Same thing. Okay, that's all it's asking. Okay, so this helps us though, because if we want the length and we have theta, which is radians, and we have the radius, all we have to do to find length is multiply the two, right? So if I want the length of zy, this tells me that I can take 3 pi over 4 times 9, or 9 times 3 pi over 4. It doesn't really matter which way you put it because you'll get the same thing. You multiply by pi? What did you say? Yeah, 3 times 9 divided by 4 and then multiply by pi also. All together? I just 3 pi divided by 4, right? So you get 21.21? Yeah, okay, I just misheard you, I'm sorry. My ears. I've got my ears checked twice, and they say I'm fine. I am not fine, but I'll pretend. Okay, so if I multiply this all together on my calculator, you should get, it says round to the nearest hundredth, okay? So you should get 21.21, and then we are in centimeters. Okay? So we're going to do the same thing over here. Remember, if we want arc length and they give us the radians for theta, okay, we want the arc length of mn. We are going to take the radius times the radians, and you can write it either way. You can say 2 times 7 pi over 12. It says round to the nearest hundredth. Anybody got it? You got it. 3.67 inches. Questions? Okay, the last thing is this circle. Okay. Now, what the directions are telling us, first of all, is that 360 degrees the whole way around is the same thing as 2 pi radians. Okay, so 360 degrees, if I go from 0 degrees all the way to 0 degrees, this is 2 pi radians. Okay, are you with me? Okay, so if all the way around is 2 pi, what's halfway around?
1 pi.
Yeah, so just pi. Okay. Does it? Then what's half of half?
Half a pi.
Right? Half pi over 2, right? So if 180 is pi, 90 would be pi over 2. Does that make sense? So then if I have pi and I have a half more, how would I write that? Yeah, 3 pi over 2. Does that make sense? Okay, because we go a half pi to 1 pi to 3/2 pi to 2 pi. Okay, now let's do the 45s. Okay, so if 90 is a half pi, 45 is a half of that, right? A fourth, yes. So pi over 4. Does that make sense? Okay. So what's a half pi but plus another fourth pi? Yeah, 3/4 pi. 3 pi over 4. This would be 4 pi over 4, right? Because 4 over 4 is 1. So the next one would be 5 pi over 4. This one would be 6 pi over 4, but reduces to 3 pi over 2. So the next one would be 7 pi over 4. And then 2 pi is the same thing as 8 pi over 4. Does that make sense? Okay. So those are our quarters. Now we got to do our 6s, right? Okay. Yeah, 30 degrees is pi over 6, right? A 6th pi. So this one would be 2/6, which is 1/3, so pi over 3. Are you with me? So 1/6, 2/6. This one would be 3/6. This one would be 4/6, and that reduces to, yep, 2 pi over 3. 4/6, right? 4/6. Okay, so this one would be 5/6. 6/6 is pi. Are you with me? 6/6 is pi. Okay, the next one would be 7/6. What's 8/6?
4
Over. Good. 9/6 is the 3/2. What's 10/6? 5 pi over 3. And then the last one is 11/6. And what you just filled out is called the unit circle. Dun, 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 dun. Unit circle. So if you were to take these degrees and multiply by pi over 180, that's what you would get for each of these. Does that make sense? Yes. This on the test? Probably not. You will use this a lot when you get to pre-calc. A lot in doing radians. Like this will be, like you will know this. Okay? I'm just introducing it to you. Okay. All right.